Hello everyone, welcome you all to another video on graph theory. In this video, we will be looking into another very important type of graph which is called Eulerian graph, also called Euler graph. So what a Euler graph is? It is a graph in which there exists a cycle in which every edge is visited exactly once and returns back to the starting vertex. So let's understand it. What are the basic properties? It should be a cycle. There should be a cycle, and that cycle, it should not exclude any edge. All edge should get included in that cycle. So every edge must be included in that cycle exactly once, not more than once, and returns to the starting vertex. Since it is a cycle, it should return to the starting vertex. So such a cycle is called Eulerian cycle or Euler cycle, and if a Euler cycle exists in a particular graph, that graph is considered as a Eulerian graph. So as per definition, a graph in which there is a cycle that visits every edge exactly once and returns to the starting vertex is considered as a Eulerian graph. So let's understand it by an example. So here we observe that if we start from the vertex D and move towards A, suppose we are starting from vertex D and we are moving towards A. From A, if we move to B, B to C, C to E, E to B, and again B to D. So all the vertices, all the edges are covered, and we are coming back to the original vertex, that is D. So we have started from D, so we are coming back to the original vertex. So it is a cycle. So a cycle is existing and it is touching each and every edge. Therefore, it is called an Eulerian graph. So the basic property, or how can we identify whether a given graph is Eulerian or not? So all the vertices must have even degree. The degree of the vertices must be either 2 or 4 or 6, whatever it is, it should be an even degree. From that angle, if you observe, suppose A, what is the degree of A? What do you mean by degree? We have already discussed what is the degree. So degree means the vertex that are connected, or the paths or edges that are connected with that particular vertex. So how many edges are connected with A? There are 2 edges. So degree of A is 2. Similarly, degree of B, 2 edges are connected. Degree of B, 4 edges are connected with B. So degree of B is 4. Similarly, for the other vertices, the thing is that every vertex must have even degree. The degree must be even number. So that is all about Eulerian graph. And since it is a Eulerian graph, we may encounter another term, Eulerian path. Eulerian path. So what is the difference between Eulerian cycle and Eulerian path? Eulerian path means there doesn't exist a cycle. Now let's take another example of a graph which is having Eulerian path. Say A, B, C, D, E, and we are having a graph like this. So in this, if we observe, if we start from E, suppose we are starting from E, then we can move to E to C, C to B, B to A, A to D, D to B. So we are touching each and every edge. That means this is an Eulerian path. Since every edge is considered, so it is an Eulerian path, but it doesn't return back to the starting vertex. Therefore, it is not a Eulerian cycle. So since it is not a Eulerian cycle, therefore this graph is not a Eulerian graph. From the other side, we can think every Eulerian graph will have even degree. The degree must be even. So what is the degree of A here? Degree of A is 2. Degree of D is 2. Degree of B is 1, 2, 3. Similarly, degree of E is 1. So since we are having degree 1, degree 3 is not an even degree, therefore it is not a Eulerian graph. So that's all about Eulerian graph. Now we will look into another category of graph, which is Hamiltonian graph. So what a Hamiltonian graph is? Just opposite to the Euler graph. In Euler graph, every edge must be visited. However, in case of Hamiltonian graph, every vertex must be visited exactly once. We may leave out some of the edges. We may leave out some of the edges if required, but every vertex needs to be visited. So, like the previous one, let's look into the definition. A graph in which there is a cycle that visits every vertex. So, every vertex exactly once and returns to the starting vertex is called Hamiltonian graph. So, this cycle that it is forming is called a Hamiltonian cycle. So, let's look into this example. Here we are starting from the vertex A. So, when can we call it Hamiltonian? If it starts from A, visits all the vertex, comes back to A. Whatever path it is taking, it should be a cycle. Let's observe. From A it is starting, it is going to B, from B it is going to C, from C to E, from E to D, and again from D to A. So it is forming a cycle. Since it is forming a cycle, therefore we can consider it as a Hamiltonian cycle because it is visiting all the vertices. It is touching B, it is touching C, it is touching E, touching D. So touching all the vertices, it again goes back to the original vertex. So therefore it is called Hamiltonian graph. So here we have to remember, in case of Euler graph, every edge must be covered. To form a cycle, every edge must be covered, and in case of Hamiltonian graph, every vertex should be covered. Every vertex should be covered, and finally it should reach to the starting vertex. So then only it is considered as a Hamiltonian graph. Let's is it Eulerian? Just by looking at this graph, we can say it is not Eulerian because the degree of D is 3. And in case of Eulerian graph, the degree should be 2. But in Hamiltonian graph, no such condition is there. The thing is that it should visit all the vertexes properly and form a cycle. So that is the basic difference between Hamiltonian graph and Euler graph. We can take some more examples. For example, a square. A square will form, if we consider a square, suppose there are 4 vertices A, B, C, D, and it is forming a square. So is it Euler? Yes, it is Eulerian because every vertex is having degree 2. So A is having degree 2, B is having degree 2, C is having degree 2, D is also having degree 2. It is both Eulerian as well as Hamiltonian. Similarly, if we consider another graph, say, why is it Hamiltonian? Because A, B, D, C, again A. So it can cover all the vertex and again reach back to A. Let's take another graph, say, so there are 5 vertices A, B, C, D, E, and the edges are connected somewhat like is it Eulerian? No, it is not Eulerian. Why no? It is not Eulerian because if you observe properly, A is having degree 2 but B is having degree 3. So similarly for C also there are 3 degrees. So it is not Euler. Is it Hamiltonian? We have to find such vertex, such cycle. Let's see. If we move from B to A to C, C to E, again it will go to B, but not directly to A. Or if we move in this way, it will not take us to the original vertex. So therefore, it is neither Hamiltonian. So nor Euler, nor it is Hamiltonian. So this that's all about two very important graph, Hamiltonian graph and Euler graph. So in the next video, we will look into the different representations of graph. Thank you all.